Hello, my name is Kevin Brooks, and I'm joined by Darren Garay and Johnny Tamayo, and we'll be going over the materials of rocket nozzles. We'll be first going over a background, then getting into history and modern rocket designs. So why do rocket nozzles need special materials? This is because in their flights, they experience high temperatures, high pressures, and because of these high pressures, extreme loadings. They also have high fluid velocities. Some science behind CD nozzles is during the converging section of the nozzle, the flow velocities are subsonic, whereas in the throat, they're transonic or Mach 1, and in the diverging section, they're supersonic. So the high temperatures that can reach over 3,000 Kelvin, and because of this, they flow cryogenic fuel through the sidewalls of the nozzle. Therefore, the materials need to withstand a high temperature differential. For the pressure and flow velocities, this is what creates the thrust. Because of this high thrust, the structure needs to survive it throughout the flight. The exit pressure is actually optimal when it's ambient, but this is not true for the rest of the rocket nozzle. Now I'll be handing it off to Johnny.
For the history of the nozzles, thermochemical and mechanical environments produce high-performance solid propellants, introduce many material problems in the developments of these rocket nozzles. Fully densified refractory metal nozzles were typically more resistant to erosion and thermal stress cracking than other materials.
Hello, everyone. My name is Darren Garay, and I'm going to be talking about the modern day rocket nozzles. First, let me give a little insight on where we used to get our rocket nozzles from. We used to purchase them off a European provider who remains the sole supplier of the RL-10 engine nozzle extensions. Increasing the prices in recent years, we have made the nozzles an expensive element of the propulsion system. To reduce the costs for this important component, NASA awarded the Carbon Advanced Technologies a contract to develop a two-dimensional process that offers an equally capable and reliable product that meets NASA's goal of ensuring long-term launch services and mission success. This left CCCAT on the search for a material that could outperform previous materials. They came across this material called ACC high melt, and they ended up using this as their material. Manufacturing these nozzle extensions with ACC high melt keeps the engine mass to a minimum for better performance while also withstanding the high temperatures of nozzle exhaust. The CCCAT nozzle extension has been tested in the arc jet environment over 3,000 degrees Fahrenheit, and the fabrication methods used will allow for slightly longer nozzles to provide greater engine-specific impulse, allowing it to provide up to an additional 100 pounds of vehicle payload with the same propellant load. The ACC high melt has been proven to be a top-performing high-temperature material. From these findings, there has been some huge benefits that come with it, like lower material and launch costs, which means saving potentially hundreds of thousands of dollars per launch. Small businesses have benefited like this, from like CCCAT, when they were contracted, they were provided with resources. Otherwise, they wouldn't be unavailable to innovate using such material previously untested for larger nozzles-like structures. And today we went over the background, the history of nozzles, and the modern day nozzles. These are our references. And thank you. I hope you enjoyed the presentation.